My name's Anna Tapper, and today we're going to be looking at developing our understanding of the number system and place value. So first of all, let's look at the aims for this session. The reason these are our aims is because a deep understanding of the number system will support all learners to progress with maths and to make the connections between the different areas of maths. It's a fundamental building block for everything else that comes along. So I'd like us to take just a bit of time to think about the sorts of misconceptions and problems the children we work with encounter around the number system and place value. Pause the video here and jot down your ideas. Whilst you're doing that, take some time to think about why this might be. Here are some of the common errors children make that I've discussed with the teachers I work with and from my own experience. Perhaps you recognise those in your jottings too. Oral counting is the ability to correctly order a string of numbers. Initially, this will involve memorising the string, so early experiences focus on learning these sequences both forwards and backwards. But children often struggle when they come to count the teen numbers, particularly in remembering 11, 12, 13 and 15, as these numbers don't sound like their ones counterparts. They don't follow the pattern of 1 teen, 2 teen, and so on. Continual repetition of counting strings of numbers and relating these to real experiences and concrete materials will support understanding here. We've found that children often confuse the teen and the T numbers as well. All teen and T numbers can be confusing as the identifying sound occurs at the end of the word. Don't worry too much, it's important not to get stuck in the teen numbers, as moving on will support children to understand the structures and patterns in our number system once they start working with larger numbers. Numbers that include 0 often pose particular problems. Careful teaching using a range of structured mathematical resources is crucial here. So place value charts are useful to organise resources and provide a clear image. Manipulating different representations of the same number supports an understanding of place value. So structured resources such as Deans, Numicon, bundles of straws, and place value arrow cards and bead strings provide clear images for understanding place value. Children may not have any conceptual understanding of negative, decimal, or very large numbers. They may also find it difficult to understand that there are numbers between numbers, or numbers less than 0. With all of these confusions inherent in our number system, you can see how it can be difficult for children to fully understand. Sometimes a comparison with another number system exposes the difficulties children can face with our own. So let's have a look at the Japanese number system. You may want to pause the video here to see what you notice. Is it an easy system to understand? For example, would you be able to say the number 11 in Japanese? Or 23? What makes this system easier is the clear structure of tens and ones. So let's look at the number 20, for example. The words are 2 tens, and the symbols show 2 and 10. I think it's worth considering the complexities of our own number system when working with young children, as it helps us understand the frustrations that they may be feeling. One way to support children to understand number is through stories. Maths Through Stories is a fantastic international research-based initiative which sets out to explore various aspects of integrating stories and literacy in mathematics. The website holds a list of stories which make mathematics teaching more accessible and enjoyable for the learners. You can search for any topic in there. It's a great way for learners to explore the number system in another context. Understanding the number system and flexibility within it at a young age helps children to keep seeing number as flexible as they start to work with more complex calculations. Here I've got an example from the book I Spy Numbers of a number collection. This one's exploring the number 3. First of all, it explores the cardinality of the number 3, the value of it being 1, and another 1, and another 1. We can see that through the 3 little pigs, or the 3 saucepans, or the 3 hearts on the cube. But it also explores the nominal value of the number 3, the number on the man's jersey, or the big number 3 in the middle. And then it also shows the ordinal value of the number 3 through the little sign that says 1, 2, 3. And there's a great example with the spatula, because here the empty space is the number 3. How fantastic is that? Take a while to pause the video here and jot down the sort of things that you would have inside a number collection. How can it support children to develop their understanding of the different aspects of number? The Enrich website is full of activities which can be used across the early years foundation stage to embed problem solving and elicit mathematical responses from children. This deep and rich exploration of number allows children to explore the flexibility in number. So when we come to problems like this, children know how to approach them. Here's a couple of common calculations that we see children struggle with when they can't employ that flexibility of number. Let's look at the first one. A child who approaches number flexibly would recognise that by subtracting 1 from 10,000, they would be able to subtract the second number without the need for decomposition. That's when we have to regroup. In the second problem, a child who does not rely on formal methods would recognise that it is easier to count on, using a mental or written number line, as the numbers are so close together, than it is to use decomposition. It's our responsibility to encourage these methods in learners, to model using them, and to give them value. That work starts in the early years, and it needs to then continue through Key Stage 1 into Key Stage 2 and beyond. When it comes to understanding the structure of number, and therefore being able to work flexibly with it, subitizing is key. Piaget recognised that children as young as 2 could subitize. That's when you look at a collection of objects and recognise the amount there without needing to count them. Most children and adults can only subitize up to 5, unless a structure is given to the objects. How many monkeys and how many strawberries are there? Can you tell me without counting? Look at how Numicon helps here. The use of this manipulative supports children to be able to recognise number and subitize. Seeing the structure in number is key to understanding what each number is made up of and how it can be adapted. We might also call this number sense. I want us to have a look here. How many cubes do you think there are? Record your estimate. How would you find out? It's far too many to subitize, isn't it? And counting them could be confusing, especially if you just counted in ones. Maybe you count in twos, or maybe you group in a different way. Does this help us? This is the same number that we had previously, so you might want to revise your estimate now. How can we count this? Well, we've regrouped the cubes. 10 ones is equal to 110, but it's still a bit difficult to work out the total value. Okay, well done if you said 313, or even close to it. Counting the tens was easier than in ones, but it's still quite hard to do. It's much easier if we regroup again. 10 tens is equal to 100. The reason we write this number as we do is simply that it's our chosen way of recording the value. So what do we need to know to understand the abstract notion of 313? Pause the video here and think about what we might need to understand to get a deep understanding of place value. These are some of the responses teachers gave to that question. We identified that children needed a strong understanding of the tenness of 10 to recognise how our number system works. So things like 10 frames and base 10 or deans really come into their own here. When I ask what the value of the digit 3 is, I'm asking you to understand the positional aspects of place value. The answer depends on the position of the digit. It could represent 300, or it could represent 3. We use the same 10 symbols to represent an infinite number system, This is what we mean by the positional aspect of place value. That's one of the 4 key things that we need to know. We've established the value of each digit through our understanding of positional aspect of place value. So now take a moment to think about why deans are useful for developing place value understanding. You could pause the video here and jot down any ideas you might have. How do we find the value of the numeral 313? Well, the value is found by adding the parts. We add 300, add 10, add 3. And this is known as the additive aspect of place value, the second of the 4 key aspects. So let's think about what the relationship is between place, or column on a place value chart, in our number system. We know that there are 10 ones, and this is regrouped as 110, and that 10 tens is regrouped as 100, and so on. The relationship between each place value is 10 times greater or smaller than the place to the left or right. We use a number system that has 10 symbols, and this is known as base 10. It's possible that base 10 was chosen because we have 10 fingers, something we should not discourage children from using as a manipulative to support their learning, even older children. We have other systems that we use. A system of only 2 symbols, binary, has 2 numerals and is a base 2 system. And time works off a base of 12 and a base of 60. And one of the main reasons it's so difficult for children to understand. In Key Stage 2, children need to develop a more sophisticated understanding of place value as they start to multiply and divide by 2 and 3-digit numbers. So here we have the multiplicative place value understanding. That's knowing that 313 is 3 lots of 100, 1 lot of 10, and 3 lots of 1. In other words, the value of the digit is found by multiplying its face value with its positional value. And this is the multiplicative aspect. When teaching, it's important that we as educators understand all of these different aspects so that we can support children to develop a rich understanding of place value. Children are fascinated with big numbers, and there are some amazing storybooks that explore these for learners of all ages. But often we see children struggle once they move beyond the thousands. Why is this? Perhaps it's to do with how abstract these numbers become, making it all the more important to ground them in pictorial representations that storybooks offer. We have deans to make 1,000, but 10,000? 100,000? Children often think that any big number is a million. Take some time now to pause the video and think about how we use the term million to denote any big number in everyday language. Can you think of any examples? Then answer the questions on the slide. How do we explain the role of 0? At the start of this session, we looked at the errors children make around the number 0. 0 really has 2 main purposes in our number system. Firstly, it represents nothing. It enables us to write in symbols the fact that nothing is left or there to start with. Secondly, it enables us to make an empty space in the number. For example, in the number 210,504, the zeros tell us that there are no thousands and no tens. Without the zeros in our place value system, it wouldn't work, as we wouldn't be able to distinguish 210,504 from 2,154. But we also use 0 to mean other things. 0 is often used to denote nothing. It is also used to create a reference point. For example, when we talk about the height of land, we mean its height above sea level. This means that someone has decided that sea level will be at 0. The freezing point of water is 0 when measured in temperature in centigrade, but not in Fahrenheit. The freezing point of water in Fahrenheit is 32 degrees. 0 Fahrenheit was the coldest temperature that can be made with a mixture of ice and salt. It's worth considering the impact our everyday language has on mathematical understanding. Thanks for engaging with this session today. Before you sign off, I'd recommend taking the time to reflect on the session and think about your own next steps for professional development. Is there something you need to find out more about? Has it made you think about the way you introduce place value in the number system to pupils? If you're interested in further reading, please see the final slide, and please get in touch if you have any questions. Thanks.